Okay, so lesson 3, examples of dilations. So now we're going to actually work with dilations and make them on a coordinate grid or on paper or on blank paper, similar to what we did in lesson 2. So we're starting with this circle here, and I want you to think about what or how many points you would need to dilate this circle by the scale factor of 3. Okay? So we're going to work through this. Do you think that 3 points would be enough to dilate the circle to look exactly the same? Let's see. Let's look at an example. If I took 3 points on that circle and did a dilation, they would be like this. Is that enough to make a circle be exactly the same? What if we had a 4th point? Would a 4th point be enough? Let's look at it. That looks like it could be some sort of quadrilateral, but I can't make a circle out of those points. So what do you think? How many points do you think we would need to make that happen? 6, 10, 15? Okay. This is probably would be enough points to make the dilation. Do you guys see this? You have to go in and you have to put in all the little bitty points, and you have to multiply the length there by 3, and I'm going to show you how to do that. Now, if you do only a few, your end result will not look like your original picture. So you have to make sure you do enough points to make this worthwhile. Okay. So I'm going to show you kind of how I go through this and do this. Okay, so what I do first is I would put, you have 1 point in the middle, A, and I would put points around it, okay, at the top and the bottom and the right and the left. A. And then I would put 2 in between each of those points, just like that. So A, and then this would be B, C, D, E, F, H, I, J, K, L, M, N. And I know that seems like a lot, but you're going to need that many points to make this happen. And now, this is where it gets a little bit more trying. Okay, so what you're going to do is you're going to line up your ruler, and I'm using the compass that has a ruler on it, with each point and draw a line. And as I do that, I'm also going to measure the distance. So from the origin, 0, 0, to A, it's 3.123. Okay, so I'm going to draw a line. And then I'm going to take 3.3 and multiply it by 3. So 3.3 multiplied by 3 is 9.9. Did I do that right? Which will be right here. That would be A prime. Okay. And then we're going to do the same thing just like that for every point. So I'm going to start with B. And sometimes I get lucky enough that I get the points on the same line. Like L and C. Do you guys see that they're going to be on the same line? Okay. L is 2.6 and C is 3.9-ish. So 2.6 times 3. It'll probably be easier if I grab a calculator. So 7.8. So I'm going to keep it lined up there. 7. 0.8 L prime, and I don't remember what C was. Shoot, was 3.9. $11.7. And I try to, as much as possible, line it up. And I probably could have done D right here, being 4, so then to 12. M and B, maybe not. Probably just B. B is at 3.7. $11.1. Whoop. M and N, we're going to work those on the same line. M is at 3 and N is at 3.4. So M would be at 9 and N would be at 10.2. Okay. Okay. Letter K. It takes a while, so make sure you take your time and don't get in a rush. Okay, do it correctly. Don't try to do it quickly because then you will mess up. K is at 2.6. 7.8. I could probably do J and F the same. Ooh. So J is at 2.8, 8.4. F is at 3.8, 11.4, and all I'm doing to get the new numbers is multiplying by 3. Okay, I gotta do E. E is up there. E is at 4, so 4 times 3 is 12. You gotta draw the line. Long process, I know, but you can do it. And I could get these last two on the same line. Thank goodness. Alright. Nope. $3.1, so 9.3. I did it right, it'd be right here. And then a 3.5, 10.5. And then you would just, that looks close enough to a circle you just connect in order. B, C, D, E, F, H, I, J, K, L, M, N, back to B. So it's not perfect, but it's pretty close to being a perfect circle. Now, if we only did, say, the top half of the circle, okay, we only dilated the top half, okay, we wouldn't have enough information. It would look something like this. Oh, sorry. We'd get this. We would only get the top points. If we did the bottom half, we'd get this. Only the bottom points. And if we did just partial, we'd get this. So we wouldn't know really where to connect here in the middle, how to connect those. Okay? So you have to make sure that you put points all the way around your shape and make it bigger. So now we're going to do example 1 and 2 here real quick. Again, same type of scenario, okay? We're going to do the same thing, but now we're using this. I'm going to put a point in the middle, that's E. Okay, we're going to scale factor this, or dilate this with a scale factor of 2. Okay, so I'm going to get a point here, my 4 points, and then 2 in between. P, Q, R, S, T, U, V, W, X, Y, Z, and I guess I'll go with A. So again, we're going to do the same thing. We're going to draw a line through each point. We're going to measure the distance from the origin to each point and multiply that distance by our scale factor, which is 2. And we're going to plot those points, and then we're just going to draw our shape. Okay, so I'm just going to start here and go around the shape as best I can. So this is 2.3, so 2.3 times 2 is 4.6. I don't know why I was having trouble with that. So at 4.6, I'd put a point, V prime. I'm going to draw a line through U. And you could name your points whatever you wanted to. Where it hits there on the circle, I'm looking here because I didn't draw my line very good through U. 2.6 or 7. I'm going to go with 2.6. Is 5.2. U prime. Yay! It looks like I can do T and W on the same line. It's the small things that make me excited. Okay. So W is at 2.1 and T, we're going to say, is at 3. Oh, we're going to say W is at 2.2. So 2.2 times 2 is 4.4. And 3 times 2 is 6. So T prime, W prime. And that is an apostrophe. It's not a 1. Okay? S. When I go through S, it's at 3.123. So 3.3 times 2 would be 6.6. So S prime. X. Can't do X and R. They're not close enough together. X is at 2.9, or no, that's E. So I could do X and E. So X is 1, 2, 3. 2.3. 4.6. And E is at 2.9. So that would be 5.8. So E prime, X prime. I could do Y and Q on the same line, so that's nice. So Y is at 2.7 and Q is at 3.8. We'll go with that. So 2.7 times 2 would be our 5.4. And we went with 3.8. So 3.8 times 2 is at 7.6. Q prime. Y prime. I can do Z and P on the same line as well. Okay, so Z is at 3.1 and P is at 3.9. So 3.1 times 2 is 6.2. And a 3.9 times 2, we just did that, is 7.8. So Z prime and P prime. And we just have to do this last one, A. Lots of lines, lots of measurement, lots of time. Oh, I didn't do it very well. Gotta shift it over a little bit. Um, 3.9 again. So 7.8. Not doing that very well. There, that line is better. And it wasn't 3.9, it was 3.5. So 7. So A prime. And then we would just connect the dots P, Q. Oh, I didn't do R. Huh, look at that. That's why it's good to double check. So R is at 3.6. 3.6 times 2 is a 7.2. R prime. P, Q, R, S, T, U, V, W, X, Y, Z, A, and back to P. So number 2 says, what shape was the dilated image? Okay, the original shape was what we call an ellipse. That's what it says right up here. That's what we're going to use. So the dilated image was an ellipse. Okay, and something I want to add here were some properties, okay? Kind of dilations, map, circles, to circles and dilations, map, ellipses, to ellipses. Okay. Now we're going to look at some examples here.
At this time, there's an NJHS meeting going on in the Performing Arts Room.
Okay. So let's look at this example. In this example, the triangle was dilated by a scale factor of 1/3. So what you do here is you would take your ruler and you would measure the length to A, which looks like it is 6, and you would multiply it by 1/3 and get 2. So you take your original length and multiply it by whatever your scale factor is and then get your new length. Okay. So if this was the original scale factor was 1/3, okay, how would we undo that dilation? How would we make it go from here to here? So to undo a dilation, we would have to do the inverse of whatever the scale factor was. So the scale factor originally was 1/3, so to undo it, we have to take the inverse of the scale factor. And the inverse of 1/3 would just be flipping that fraction over. So our scale factor to undo it would be 3. Okay. And we can do that with the definition of a dilation. We knew that this whole length here was 6, so the distance from O to A was 6, and the distance from O to A prime was 2. Okay, and we can solve for the scale factor of 1/3. But we can see to get from 2 to 6, we would just multiply by 3. Okay. Let's look at another example. In this example, the triangle was, I have it upside down for you guys. Isn't that exciting? The triangle was multiplied by a scale factor of 4. Okay, so the original is a small triangle and it got bigger, so our scale factor was 4. Okay, and if we were to undo that, okay, we would just take the reciprocal or the inverse of this. So the reciprocal of that would be to undo it. Okay, our scale factor would have to be 1/4, 1/4. Okay. So essentially, whenever we're wanting to undo something, we're going to take whatever our scale factor is and flip it. If it's a fraction, just like here, we took the scale factor and we flipped it. If it's not a fraction, we're going to put it over 1 and then flip it. Okay, so now we're going to look at exercise 3 really quickly. So here we go. It says triangle ABC has been dilated from center O by a scale factor of 1/4. Denoted by A prime, B prime, C prime using a centimeter ruler. Verify that it would take a scale factor of 4 to map A prime, B prime, C prime onto triangle ABC. So here's our small one. So we're going to just look at this. Okay, so we're going to measure from O to A prime, the distance from O to A prime, the distance from O to B prime, and the distance from O to C prime. We are also going to need to know the distance from O to A, the distance from O to B, and the distance from O to C. Okay, so we're going to have to measure all those things and then use them to do some investigating. Okay, so centimeter ruler. Oh, I'm going to do it the other way. O to C prime, and we measure from the center of the dot to the center of the dot. Looks to be about 1.5. And O to C looks to be about 5 point 6. We're going to say this is 6. Okay, O to B, and I'm just going to give you these measurements real quick, is 1.3. And O to A is 2. And these are all in centimeters. O to A is 8 centimeters. O to B is 5.2 centimeters. And O to C, we're going with the 6 centimeters. Now, if you measure this won't be exactly, this are just examples, because when you print it, it doesn't necessarily keep them exactly the way you have. Okay, but you can see that 2 times 4 is 8, 1.3 times 4 is 5.6, and 1.5 times 4 is 6. I can't do this today. Multiply this to get this by 4. Multiply this by 4 and get this. Multiply this by 4 and get this. Okay? Okay, so essentially we're starting here with a summary. Dilations map circles to circles and ellipses to ellipses. If a figure's scale is dilated by a scale factor R, we must dilate it by the scale factor of 1 over R to bring it back. So that's the reciprocal or inverse. Okay, so if it's dilated with a scale factor 4, the reciprocal would be 1/4.